Hello students, in this session we'll take the questions of application of derivatives and maxima minima. So let us begin. We'll take the first question. So students, in this first question, it's a very simple question. A point x equal to c is called the critical point of a function. If f dash c is equal to 0, which is true. If f is not differentiable at x equal to c, students, if f is not differentiable at x equal to c, then derivative will not exist. But that is not true. Derivative exists, it has to be 0 at that point. So therefore, this is not the correct option, and therefore option A is correct. We'll move to the next question. We have question 31 as the next one. Now, in question 31, students, y is x raised to 5 plus x cube, x belongs to R, is a function. Reena, Abha, and Saurabh have given their opinion about the function with the following statements. Now, Reena says that y is an increasing function for all values of x. Now, students, I hope you know how to check whether it's an increasing function or not. So we'll take the derivative of this. Derivative of this will be 5x raised to 4 plus 3x squared. Because x raised to 4 and x squared will be positive for all values of x, we can say, students, that this derivative will be positive. And therefore, what Reena is saying is true. It is an increasing function. Abha says that y is an odd function. Now, for odd function, students will have to check by replacing x with minus x. So it will be minus x the whole raised to 5. This is minus x the whole raised to 3. So this, students, is minus x raised to 5. This is minus x cube. We take minus common. This is x raised to 5 plus x cube. Now, students, we have come back to the negative of original function, and therefore it is odd function. So what Abha is saying is true. It's an odd function. Now, students, we have discussed in the previous video, I hope you have seen that video, of important concepts for these MCQs, that when it's an odd function, it is going to be symmetrical about origin. We had discussed this with the help of a graph. I hope you recall that. So therefore, students, we can say that what Saurabh is saying is also true. So all the three are correct. So option A will be correct. We'll proceed to the next one, students. Question 42. Now, students, in question 42, there is one correction which you have to make before we proceed. This should be local maximum. You make that correction, and now we'll take this question. In question 42, don't really get scared by seeing this new symbol delta. I'll tell you what is it all about. So first, let's focus on the assertion and understand whether it's true or false. So f of x is a polynomial of degree so and so. We have this derivative. So derivative is already given to us, students. When we check the critical points, like those points where the derivative is 0, do you understand, students? We'll get x is 2, we'll get x is minus 1, we'll get x is 2 by 7. These are the points where it is minimum. Now, students, over here, our focus is only at x equal to minus 1. So on my rough number line, I'll be making only minus 1. I'm not really bothered about the other numbers right now, so I'll not focus on that. Now, students, over here, we have to decide to the left of minus 1 and the right of minus 1, where is it positive, where is it negative? I'm basically testing this with the first derivative test. See, the second derivative test here is going to be very difficult because the second derivative itself is going to take some time. So what I'll do is I'll test this with first derivative test, whether the minimum is at x equal to minus 1 or not. To the left of minus 1, students, let's take any random number. To the left of minus 1, I'll take minus 2. When we substitute minus 2 in this, now see, I don't really want the answer. I want to know whether it's positive or negative. I'm not bothered about the value. So when we take x as minus 2, this will be negative whole cube, which is negative. So this is negative. When we take x as minus 2, this will be negative whole square, which is positive. When we take x as minus 2, this is negative. So do you understand, students? The overall function is going to be positive. And therefore, we can say that it is positive when x is minus 1. When we take x as when we take anything to the right of minus 1, students, let's say we take 0. When you substitute 0, this is negative whole cube, which is negative. This is positive, this is negative. So this is also going to be positive. What I want you to understand here, students, is that minus 1 on the left also, it is positive. On the right also, it is positive, which means it is positive, and therefore it's neither maximum. When will it be maximum? It will be maximum when it is positive, negative. So it's increasing, decreasing. That is when it will be maximum. When will it be minimum? When it is decreasing, increasing. So negative, positive. But if it is positive, positive, it's basically an overall increasing function at x equal to minus 1. And therefore, we can say, students, that this is neither maximum nor minimum. So assertion is false. So assertion is false. Coming to the reason which they have given, students, is actually the definition of the first derivative test. Now, in the previous video, we have discussed the first derivative test. I'm sure you have already noted it down. If you check and compare, students, the term I had used was h. Here, they are using delta. If you look at this delta, if I take it as h, it's the exact same definition that we have written. So here what they're saying is, students, that if f dash c is greater than 0, to the left of c, we're talking about c minus h. So students, at a particular point c, to the left of c, if it is greater than 0, so if it is an increasing function to the left of c, and it is less than 0 to the right of c, it is less than 0 to the right of c, here, students, do you understand, this is the point of maxima. And that is why the reason that they have mentioned local minimum, that is incorrect. It has to be local maximum. And the reason is true. If you're thinking that, sir, it can be, reason is also false, assertion is also false, we don't have an option like that. So definitely it's a printing error. You have to make this correction. The correct answer will be assertion is false, the reason is true. We're done with this question. We'll move ahead. We'll go to question number 45. Now, students, question 45 is a graph-based sum. The function is given, but we are not really going to use it. Now, we have to find the maximum value of this function. Students, maximum value basically means the highest y coordinate for this graph. Now, if you look at all the infinite points on this graph, which point has the highest y coordinate? So, do you understand this point has the highest y coordinate? It's the topmost point for this function. And the y coordinate here is 0 because it's on x-axis. So, therefore, this is true. About the reason, students are saying the minimum value approaches infinity. Now, you must be wondering that yes, the minimum value is approaching infinity. This will keep going on till infinity. But students, just be careful with minute details. We had one question yesterday. It had some minute details where we missed it. Over here also, it's supposed to be negative infinity, students, because it's in the negative direction. You'll have to be careful with these very minute details. So the assertion is true, reason is false, and therefore it's going to be option C. We'll proceed, students, to the next question. The next question that we have is 55. Question number 55, the displacement x meters of a particle is given at a fixed point at time t. So x is given as 6 cos of 3t plus pi by 3. To find the acceleration of the particle when t is 2 pi by 3. Now, we have discussed that acceleration is basically the double derivative of displacement. So when you take the first derivative, that will be velocity function. So derivative of 6 cos 3t plus pi by 3 will be 6 into minus sine of 3t plus pi by 3 into derivative of 3t plus pi by 3 with chain rule, which is 3. Further, students, when we take the derivative of this function to find the acceleration, we have minus 18 as constant. I'll keep it outside. Derivative of sine is cos. So we have cos of 3t plus pi by 3. And we'll multiply it with 3 again with chain rule. So this is minus 54 cos 3t plus pi by 3. And at the end, students, we have to substitute t as 2 pi by 3. When you substitute t as 2 pi by 3 in this, you will get minus 54 cos of 2 pi plus pi by 3. Now, students, if you remember the allied angle formula, you can proceed with that. If you don't, use your calculator, finish it off, and you'll get the answer easily. I leave that part up to you. I hope you get it. If you don't, you can text me on the chat box. I'll get back to you. Further, students, the next question that we have is question 73. Rahul sits on a speedboat in an island to do water sports, which is moving along a curve. Y is equal to 1 upon cos x sin x. We have to find the number of stationary points. Now, students, when we talk about stationary points, we're talking about those points where derivative is 0. So over here, students, we'll have to take the derivative of this function. But let's simplify this function first. When you see cos x sin x, I'm sure something has to click. Do you recognize this is very close to a trig formula? If I adjust the 2, multiply divide with 2, then this, students, is sine 2 theta. So therefore, I'll multiply divide with 2. So this becomes 2 upon sine 2x. And therefore, this is 2 cosec 2x. Now, students, you have to understand I'm doing all this to avoid UV rule of derivative. I don't really want to do u upon v. It's too much work. Now, we take the derivative. Cosec has a direct formula. Cosec theta is minus cosec theta cot theta. So this is minus cosec 2x cot 2x into derivative of 2x is 2. So this is minus 4 cosec 2x and cot 2x. Now we have to equate this with 0, students. Not many students may be comfortable with cosec and cot. So I'm going to convert this to sine and cos, which is not mandatory. If you're comfortable with cot and cosec, go ahead and finish the sum. You'll get the same answer. So here, when we convert this to sine and cos, this is going to be 1 upon sine 2x. This is going to be cos upon sine. So cos 2x upon sine 2x. Now, students, do you understand that this will be 0 if numerator is 0, which means we get cos 2x is 0. So you have to now figure out, students, that cos 2x is 0 for which values of x. Over here, the range is not mentioned. We'll assume it as 0 to 2 pi. And when we say 0 to 2 pi, do you understand? Cos of 90, that is pi by 2, is 0. And therefore, cos 3 pi by 2 will also be 0. So 2x is either pi by 2 or it is 3 pi by 2. And therefore, we get x is pi by 4 or 3 pi by 4. So there are 2 stationary points. The question is number of stationary points. There are 2 stationary points. We'll proceed, students. We'll move to question 75. Question 75 is super easy, students. You can run through it. So here they have given some story. Please read it. Y is equal to 4x minus half x square. That is the displacement curve. And we have to find the rate of change of displacement. Students, rate of change of displacement simply means derivative. So we'll take derivative of y with respect to t. So that will be 4x. Over here, students, because they've given that time is x, we'll write it as derivative of x. They have denoted that x is time in seconds. So that will be derivative of 4x, which is 4 minus derivative of x square is 2x, or 2x by 2, which gives us the answer. It is 4 minus x. Now, how many seconds will it take her to go to its maximum height? This is a very basic sum, students. It's basically Maxima Minima. We can do it with the double derivative test. I'll equate this with 0. So we get x is equal to 4. When we take the double derivative, students, the double derivative in this case is derivative of 4 minus x, which is minus 1, which is negative. And therefore, we can say it is maximum at x equal to 4. So how much time, how many seconds will it take? 4 seconds to reach the maximum height. It was a very simple question. We'll move ahead to question number 77. In question 77, students, they're saying it is given that 2 times f of x is equal to log of x raised to a minus bx squared plus x. If f of x has extreme values, when we say extreme values, it's either maxima or minima. Now, in this sum, students, they have not given that at which point it's maximum or minimum, but they have at least given that it is maximum minima at -1 and 2. So here you have to understand, students, that at those points where it is maximum minima, the derivative for sure is 0 because they are the critical points. So we'll take the derivative of this equation, students, equated with 0. So here, when we take the derivative of this equation, it will be 2 times f dash x equal to. Now here, students, we have log of x raised to a. When we use the rule of log, this is a log of x. I hope you understand this. A will come down. It will be a log x. When you take the derivative of this, students, it's a by x minus b into derivative x square is 2x. So it is 2bx and we have plus 1. This is the final derivative. Now at x equal to -1, do you understand, students, that derivative is 0. So on the left, we can substitute 0. This is a upon -1 minus 2b into -1 plus 1. From here, students, will get the first simultaneous equation, and that equation is a minus 2b equal to 1. Once you get the, students, we'll have to do the same thing with x equal to 2. So it's going to be 2 times, when x is 2, f dash 2 is 0. So on the left, we'll again have 0. 0 is equal to a by 2 minus 2b into 2 and plus 1. So when you solve this equation, students, you will get a minus 8b is equal to -2. I leave the solving part up to you. I'm sure you can manage the simultaneous part. You'll get a and b from here. Next, after 77, we have question 91. In question 91, students, the function f of x is given, g of x is given. You have to find f dash x. We'll take the derivative. F dash x is equal to -2 into x minus h. Derivative of 2k will be 0. Now, the graphs of f and g have a common tangent at x equal to 3. If they have a common tangent, students, do you understand that slope is same? And slope means derivative. Slope of tangent means derivative. We already have f dash. We'll now find g dash. So g dash is going to be e raised to x minus 2. Derivative of k is 0. Do you recognize, students, that when they say the slopes are equal, I can equate -2 into x minus h with e raised to x minus 2. Here, students, the value of x is already given. The x is given, it is 3. We'll substitute x as 3. So we get -2 into 3 minus h is equal to e raised to 3 minus 2. And we are done, students. You open the brackets, it's -6h, -6 plus 2h equal to e. So from here, we get 2h is equal to e plus 6. A super easy question. We'll proceed, students. We'll take question number 93. In question 93, students, the function f of x is given to us. Now we have to show that f dash x is this. So we'll take the derivative with uv rule. So the derivative is going to be v. Derivative of log 5x is 1 upon 5x into derivative of 5x by chain rule. So that is into 5 minus u is log 5x into derivative of kx is k, the whole upon v square. So that's k square x square. When you simplify this further, students, this x will get cut, the 5 will get cut. We are left with k minus k log of 5x upon k square x square. You can take a k common, students, and cut 1k. We'll get 1 minus log 5x upon k x square. So that proves the first part. In the second, we have to now show that the graph of f has exactly one maximum point at P. When we say maximum minima, students, will equate the derivative with 0. So f dash x has to be equated with 0. We have to show that it has only one value of x. Now, students, the denominator will not play a part. We will have 1 minus log 5x is equal to 0, which means log 5x is equal to 1. I hope you remember that log of e is 1. So I'll take it as log of e, which means, students, 5x is e, and therefore x is e by 5. So we have only one point, and that point is x equal to e by 5. Now, to show that it has maximum, we'll have to check the double derivative and substitute the value of x. About the second part, the coordinates of P. So P, students, x is e by 5. Now we'll have to find the y coordinate, student. For y coordinate, we should substitute this in the original function. So let us do that working and find out the y coordinate for P. Now for P, students, the y coordinate will substitute in y is equal to log of 5x upon kx. So we have y is equal to log of 5x upon kx. So y is equal to log of 5x, students, in this case is e. So log e is 1 upon k into e by 5. So this is basically 5 by k into e. So this is 5 by k into e. For the students, we have to find the double derivative. I leave this part up to you. You take the derivative of this. And we have to find the value of x for which f double dash x vanishes. So you find the derivative, you equate it with 0, and you'll get the answer. In question 97, students, it's actually a basic sum of increasing, decreasing. The only thing is you have to manage this derivative and the simplification of the derivative, which will not be very difficult. So let us begin. We'll take the derivative first. They have given the derivative. You must be thinking they've given the derivative, but that derivative has unknowns p, q, and k. So we'll find the derivative from here. We'll compare it with this, and we'll find p, q, and k. So over here, students, the derivative is 2 log x minus 2. The derivative of that will be 2 upon x minus 2 minus derivative x square is 2x plus derivative 4x is 4. Derivative 1 is 0. So we have to now simplify the, students, with LCM. This is 2 minus 2x into x minus 2 plus 4 into x minus 2. upon x minus 2. You open the bracket, students, this is 2 minus 2x square plus 4x plus 4x minus 8, the whole upon x minus 2. When you solve this further, students, will get 4x and 4x is 8x minus 2x square minus 6 upon x minus 2. Now, what is common over here, students? I can take minus 2 common. So in the bracket, we have x square minus 4x plus 3, the whole upon x minus 2. When you do splitting the middle term, students, we will get x minus 3 and x minus 1, the whole upon x minus 2. And now, students, you have to just compare. So here k is clearly 2. Now p or q, either of them will be 1 or 3. It doesn't matter. We want the addition at the end, so it doesn't matter. And k is 2. We have already figured that out. So k plus p plus q, students, is simply 2 plus 1 plus 3, which is 6. So here we get k plus p plus q is 6. Now, this statement, we have to check whether it's true or false. Now, here they are saying that this statement is false. We have to justify. So, students, this function is strictly increasing, is what they are saying. For checking increasing, decreasing, we have to take the derivative. Now, you already have the derivative. This is the derivative. Let us use the wavy curve method, students, the method of intervals. Here, we'll take the values 1, 2, 3. The values of x will be 1, 2, 3. So now, students, to the left of 1, I'll take any number. Let's take 0. If you substitute 0 in this is negative, this is negative, this is negative. And here in the function itself, we have negative. So we have 4 negative signs, which means it is positive. So this is going to be increasing. And then it's always alternate, positive, negative, and positive. So students, these are the two regions where it's positive. So it will be x belongs to minus infinity, comma 1, where 1 is not included, and 2, comma 3, where it is not included. So students, they are saying that this is false. We have to justify. Now, if you're thinking that this is true, how is it false? You just have to focus on these minute details, students. The bracket. They have included 1 and 3, but they are the critical points. So we'll not say that they're increasing, decreasing at that. We'll just say that it's increasing, decreasing at these points where 1 and 3 will not be included and 2 will not be included. So the interval where it is strictly increasing is this. You can't include 1 and 2 and 3. All right, with that we complete this sum. That's it for this session. We're left with few more questions, which I'll take in the next video. Do join in for the next video for the other set of questions from application of derivatives and maximum minimum. Thank you.